Salutations, brothers. This is 217 contains duplicate. This is a pretty simple problem, but I think it's a great problem to build foundations on, so we're doing it anyway. Hog champion. Given an array of integers, find if the array contains any duplicates. Your function should return true if any value appears at least twice in the array. It should return false if every element is distinct. So we have some values here. 1 appears twice, so this array contains duplicates, so we're going to return true. False here because all these numbers are distinct, so on and so forth, right? So there are a couple different ways to do this. So the first way, right, is you could, let's say you have a list of numbers. We're just going to say just like the output that they mentioned there. What you can do is you can actually, there's a dictionary method and there's a sorting method. So what you could do is you could sort this, and what you would get is you would get 1, 1. Oh man. Okay. Oof. Okay, that was like calculus for a second. We're gonna have 1, 1, 2, 3. And what you could do is just linearly iterate through the sorted list of numbers and just check the number in front of it. Obviously, you'd want to go -1 so you don't go out of bounds. You would just say, hey, is the number next to it the same as the number I'm at? Like, is I equal to I plus 1? It's true here. So this array contains duplicates. You return true. If this wasn't here, let's say it was something like this, you'd say, oh, this doesn't contain duplicates, next to. These are duplicates, return. Now, why don't you want to do it this way? You don't want to do it this way because sorting a list, the fastest you can sort a list with quicksort, is n log, or the worst case is n log n. And so the problem there is that we can do this in linear time. And if we sort the list first, your algorithm is going to be bounded by n log n, which is worse than linear time. So this is the reason why you should use a dictionary method instead. So if you have, of course there, what you trade with the method from before is that you wouldn't use any space, so you'd have constant space. With this one, you're going to have linear space as well. But, you know, pros and cons. So what's cool here is you can use a dictionary, and I'm just going to call this ndict, and set it to the default dictionary of integer values for a default value for integers, which is int, which is 0, I mean. And then what we're going to do is we're going to create a mapping. So if we take that same list we took before, we're going to create a mapping of number to occurrences in this dictionary, kind of like you would literally look up something in a dictionary. There's a unique word for every word in the dictionary, right? And you can look up that word. You can only look up words because the words are unique. So if you look up cat, there's only one definition of cat. Well, you can't really look up cat probably. But what we can do here is do this. 1, we'll literally linearly iterate through the string, and then we'll just count the occurrences. So let's just do this right now. We're at 1, so we're going to set 1 to 1. And then we're like, oh, at 2. Okay, we found a 2. We'll set that to 1. Okay, we found a 3. We're going to set that to 1. Wait, we found a 1 again. That's 2. That's no bueno. We return true here. It contains duplicates. So quick way to do this, you can just, so we create our dictionary up here. We're just going to linearly iterate through the numbers. And we're going to say if number in number sub dict. So if it's in there, then we're just going to return true, right? We don't really technically have to increment it to and then check if something's greater than 1. If it's already in the dictionary, then it's a duplicate, right? Else, we're just going to add it to the dictionary. We're just going to say n sub dict equals number. N sub dict equals, number equals 1. And if you make it this far, then there's no duplicates, right? Because if there was, we would have caught it in here. And so there's one more thing you want to do, right? You always want to consider our edge cases here. So if there's one item in the dictionary, peep this out. We're going to linearly iterate through a 1-element list. For number in nums, if numbers in num dict, well, it's not, right? So we're going to go to else. We're going to say n sub number equal to 1. So we have one occurrence of 1. And there are no duplicates. Wait a second. Oh yeah, there's no duplicates, right? So one thing you can do, right, to save the time, that is always going to be true no matter what the number in here is, right? So this, you don't really have to do this, but it's important to do just to, save time. Like, just a good idea to always kind of think of this. Also, our spacing is all off, man. So we can do, right, if every list of length 1 is going to contain no duplicates, then let's just say that, right? Say that then. So we can do, if the length of the numbers of the list is 1, we're just going to return false. There's no duplicates. There's only one number in the list. How can there be duplicates? First time doing this problem, by the way. Also, okay, I did this problem first time, easy mode, but I kept getting messed up on syntax. Oops. So yeah, that is contains duplicate. Good problem to just practice. You run into this a lot. It's a kind of the founding, kind of a building block of several other algorithms that you can use to solve problems. So it's a good idea to have a good grasp on it.